So today we're going to be learning about how to determine the roots using discrimination. When you use discrimination, you use the discriminant. And what the discriminant is it's part of the quadratic formula. Which is this. The discriminant is just the part underneath the radical, so b squared minus 4ac. So the first thing we're going to do is talk about the steps in determining the roots by using the discriminant. So the first step is you need to get the equation into standard form. And standard form is ax squared plus bx plus c. And that's how you're going to be able to find the numbers that you need to plug into the discriminant. So the second step, after you get it into standard form, is you're going to simplify the discriminant. And remember, the discriminant is b squared minus 4ac. So what you're going to do is you're going to plug in the values of a, b, and c. You're going to plug a, b, and c values into the discriminant, and then you're going to simplify it. And the third and final step is you're going to determine the number and the type of roots based on what you solve for as the discriminant. So first we're going to try some examples. Now remember, step 1 is to convert the equation into standard form, which would be ax squared plus bx plus c. But as you can see, if you look at our example, it's 10x squared plus 11x minus 6. It already is in standard form. So right from the equation, we can determine what a is, what b is, and what c is. So 10, that would be a. 11 would be b. And negative 6 would be the value of c. The second step is what we have to do is we have to simplify the discriminant. And the discriminant is b squared minus 4ac. So what you're going to do is you're going to plug in the values that we already found for a, b, and c, so 10, 11, and 6. So if you plug those in, b is 11, so 11 squared minus 4 times a, which is 10, times c, which is negative 6. So now to complete step 2, what we have to do is we have to simplify this. So 11 squared is 121. Negative 4 times 10 is negative 40. Negative 40 times negative 6. Negative times negative is a positive. So it would be positive 240. And then if you add 121 to 240, you're going to get 361. So now what we're going to do is we're going to use this number we're going to use 361 in order to find out the roots. So the first thing you have to think about is 361, is that greater than or less than or equal to 0? So 361 would be greater than 0. So the fact that 361 is greater than 0 means that your roots are real roots. They're real numbers. Next thing you have to think about, what is the square root of 361? Is it a perfect square? And in the case of 361, it is a perfect square. because 19 squared is equal to 361. So, since 361 is a perfect square, that means your roots are rational. And another thing, that the fact that 361 is greater than 0, another thing that tells you is not only are your roots real, but you also have 2 of them. If 361 was less than 0, that would mean if 361 was less than 0, that would mean you'd have imaginary roots. So really you'd have 0 real roots. If it was equal to 0, you would have 1 because the graph would just barely touch the x-axis. So now we use the discriminant and we determined that this problem has 2 real rational roots if we were to graph it. So if we were to graph 10x squared minus 11x minus 6, since we've determined that there's 2 real rational roots, what does that really mean? Well, that means that if you were to graph it, these aren't the exact points, but it would look something like that, where it intersects the x-axis 2 times, because it has 2 real rational roots. So here's our next example, x squared minus 3x minus 9. So step 1 is to convert it to standard form. Standard form, ax squared plus bx plus c. It is already in standard form, so we can determine that a is equal to 1, b, right here, would be equal to negative 3, and c be equal to negative 9. Now step 2 is to simplify the discriminant. B squared minus 4ac. So if we plug in the values, b is negative 3 squared minus 4 times a, which is 1, times c, which is negative 9. So negative 3 squared, negative times negative is a positive, so negative 3 squared would be equal to 9. Negative 4 times 1 is still negative 4. Negative 4 times negative 9, negative times negative is positive, so it would be positive 36. And 9 plus 36 is equal to 45. And now the third and final step is to determine the roots. So we got the discriminant is equal to 45. So is 45 greater than or less than 0? It'd be greater than. So now we know we have 2 real roots. So now we need to find out if they're rational or irrational. And how we're going to do that is to see it is 45 a perfect square? And it's not. So since this is not a perfect square, that would mean that this equation has 2 real irrational roots. Since they're real, they would still intersect the x-axis at 2 points. So we're going to do this example now. So step 1, we have to get it into standard form. Now, unlike the other examples we've had so far, this one is not in standard form. So we're going to add 13 to both sides. And then we would have x squared minus 4x plus 13. So now we've got it into standard form. Now that it's in standard form, we can determine what a is and what b is and what c is. So by looking at the equation, A would be 1, B would be -4, and C would be 13. So now we're going to plug it into the discriminant, into b squared minus 4ac. B is -4, so we have -4 squared minus 4 times a, which is 1, times c, which is 13. -4 squared, negative times negative is a positive, so we have 16. -4 times 13 is -52. And if you solve 16 minus 52, you get the answer is -36. So now it's time to determine the roots. So first thing, -36 is less than 0. Since it's less than 0, that means that we still do have two roots. They're imaginary, meaning that if we graph it, they'll never touch the x-axis. And since they're imaginary, they wouldn't be rational or irrational because they're just imaginary. So I'm going to show you what it looks like to have two imaginary roots. If you were to graph it, the graph would never touch the x-axis because the roots are imaginary, which means they don't really exist. So here's the last example we're going to do today. So step 1, convert it to standard. So we're going to subtract 6x from both sides. We're left with 3x squared plus 6x is equal to -3. Still not in standard, so we're going to add 3 to both sides. And now we're in standard with 3x squared plus 6x plus 3. So now we can determine what a is equal to, what b is equal to, and what c is equal to. So a is equal to 3, b is equal to 6, and c is equal to 3. So now we can plug it in to the discriminant. And the discriminant is b squared minus 4ac. So b is 6, so it would be 6 squared minus 4. A is 3 times 3. C is 3 times 3 again. 6 squared is equal to 36 minus 4 times 3 times 3. 4 times 3 is 12. Times 3 is 36, so it would be 36 minus 36, which equals to 0. So now we've solved for the discriminant. The discriminant is equal to 0. Since 0 is equal to 0, which means you're only going to have one real root. If you were to graph this, the graph would touch the x-axis, but it would only touch it in one point because you only have one root. So things to remember: when the discriminant is greater than 0, that means that you're going to have two roots, two real roots. If the discriminant is less than 0, that means you're going to have imaginary roots. And if the discriminant is equal to 0, that means you're going to have one real root. And the other thing you need to remember is that the discriminant is a perfect square. That means that your roots are rational. If it's not a perfect square, then they're irrational. So that's how you determine the roots using discrimination.